So my title today is Crop Troubleshooting and Field Scouting, or perspectives from somebody who used to be outstanding in their field. But these days I find myself more standing on the edge of the field a lot of the time, and collecting imagery and flying some UAVs over some of our research plots. I'm an extension person, so I'm not a hardcore academic. I deal mostly with farmers and suppliers, and provide ag education. I do a little bit of research as well, and one of the niches that I've kind of worked on our team is with using UAVs. But how many of you currently are operating UAVs? So, all right. So if you heard Terry and you heard Brent and then listened to lunch, there's a lot of common threads here, a lot of things they're going over. I've kind of dropped a few things out here just to highlight some of my experiences, stuff that's been covered in some of the other sessions a little bit already. But to understand where I'm coming from, my drone story started back in 1979. I was between my junior and senior years of college. I was an ag student at Western Illinois University in Macomb. And I was over 21 years old that summer, and so there was a fair amount of beer drinking that was occurring. I had a decent car that I was driving around. I happened to meet the woman that I was later going to marry, and we started dating that summer. And so I had some very late nights with the combination of beer drinking and new girlfriend. But I was spending my day, and to also set the stage, in the summer of 1979, the hot music of the era was Donna Summer and the Bee Gees, but I was kind of more along the lines of the Eagles. The movies from that summer were things like The Muppet Movie, Moonraker, where Jaws made his appearance in the Bond flicks, and Roger Moore was the character. But there was a lot of horror movies that summer. Things like Alien and Amityville Horror were some of the blockbusters from that summer. My horror that summer was cornfields. I took a job that summer as a crop scout, a commercial crop scout for a crop consulting service. And things started off really nice, walking freshly planted fields of corn and soybeans, cover a lot of acres pretty quick. You could see a lot from just standing out in the middle of a field. But as the summer wore on, the soybeans got taller, and going out in a dewy soybean field first thing in the morning is not necessarily a real fun experiment or experience. And then as the corn got bigger and bigger, the challenge to see as much of the field as we were looking at earlier was harder and harder. The act of walking through the field became more of a challenge, and you get scraped up. You'd walk into large spider webs that were scattered across the row. And I discovered that even though I'd grown up on a farm and lived in the middle of cornfields all my life, that when you spend all day walking through pollinating cornfields, you will develop allergies to corn pollen. If you spend that much time, because we were coming out of the fields, and I'd take my scouting knife and I could just scrape the pollen in chunks off of my skin. So it was great training to be an agronomist. Saw a lot of acres, saw a lot of fields, and it was really a good experience. And I guess I didn't learn much from it, because the second year, actually when I graduated, I took a job as a full-time agronomist for this consulting firm. But before July got there, I'd gotten a phone call from the University of Illinois saying, "Would you like to come work for Extension?" I said, "That sounds like a really good idea. I really like 4-H. I like working with farmers. I like helping them solve problems. I don't like selling things quite so much." I talked to my boss, and he said, Extension's a great career and you should go there. And so 34 years later, I'm still in Extension. But I've always had this in the back of my head. If there's things that we can do to make our scouting and crop troubleshooting a better and more efficient process. I knew that on those days when I was going into those pollinating cornfields, if those rows were a half-mile long, I was not going to see the far end of the field. I'd go in a little ways, I'd take a few random samples, and then I'd get back out and move on to the next field, because my boss had an expectation of how many acres I was going to cover in a day. And so I had to make sure I got those covered and could report in that they had been looked at. So as I started hearing about remote sensing back in the 90s, when I first started getting information about remote sensing, I thought, this is something that can help us monitor crops during the growing season and make better decisions. But the challenge was always, what did we have to work with for remote sensing, and what kind of resolution? What could we see with the imagery? And it kept getting better over time to where you could start getting in and seeing actual field level stuff and more high resolution. The first remote sensed image that I got to work with as a crop scout was for extension, and on this kind of ground truthing, a research project with a company called Resource 21. They were looking for some people to help them out with the project. They had a joint effort with NASA to try to commercialize some camera packages that NASA had developed for satellites. And a friend of mine ended up being a part of that project and working with the Stennis Space Flight Center out of their commercialization lab to try to develop a camera package that they could put up onto cheap satellites and get into orbit and go into the market of selling this imagery to farmers. And so in the meantime, before they actually put the package on a satellite, they strapped it on an airplane, and they were flying around the country, and they had a few test fields, and one of those was in my area of East Central Illinois. And so this was the first image that they sent me, and it's a 160-acre cornfield, so it's a half-mile square, and it's half-mile square, and there's two 80-acre fields laying east and west, left and right. And on the north half of that is corn, and the south half is soybeans. So it was a good field for this project to look at. And we started seeing all kinds of things with this imagery, some of which was pretty obvious. We got a dark green strip up at the top of the screen where the corn was planted 2 weeks earlier than the rest of the corn. We've got moisture patterns showing up in the field. In the corn, that modeling area are high and low areas of the field. But looking at the image, you got to adjust your eye a little bit that in the corn area of the field, the green is the best, the dark green is the best, and the yellow is the worst. When you get down to the soybean area of the field, the yellow is the best, and the darker red is the poorer looking areas of the field. The dark area, the poorest area of the field is down here in this corner, and there was herbicide drift from a cornfield across the road down here, catty-cornered across from the field that damaged those soybeans. Also, as we were looking at this, and then we saw that all season long, that there definitely seemed to be a distinct difference between the east and west half of the soybean field. We talked to the farmer that was farming the field, and he said it had always been farmed as two whole 80s east and west. We talked to the farm manager at the bank that was managing it. He went back into his records and found that 20 years previously it had been farmed north and south instead of east and west. So we were detecting things in imagery that were over 20 years old, some kind of a legacy that was affecting crop growth that much later. And a few weeks after this, all of a sudden this was all looking much more evenly green as it continued to develop. And all of a sudden, right about in here, this streak just stayed yellow and never greened up. And these are basically, I think these are 10-meter squares is what the imagery was working on at that point. And we talked to the farmer, and the nitrogen applicator had run out. He tried to patch it back in, but he didn't know exactly where he'd run out, and he'd missed that area of the field. And the roads are here and here. And as a crop scout, I would never have made it back into the middle of that section to find that. But we saw it, and we could go in there with a rescue treatment and add some extra in if it had been a big enough area to make it worth his trouble to go to get an implement back in there. If it had been a bigger area of the field, I'm sure they would have tried that. So that was my first experience with remote sensing. I saw a lot of value with the ability to do this, that we could see this spatial variability in the field. We know it's there. We can identify some of these areas that you wouldn't be able to see from a scout, from the ground, and be able to turn these into actual data layers that we could put into a GIS system to add to our data, look with our yield maps, establish some historical records of what was going on during the growing season to match up with the yield map at the end of the season. Since these are digital, and if we can have them geo-referenced, you can compare one set of images to the next set of images and actually do delta maps or change maps from one time to the other if those images are geo-referenced and calibrated. Then I started hearing about UAVs in collecting remote sense data. Robert Blair in Idaho. And heard him speak at an InfoAg conference down in Springfield. And this got me thinking about it. And I realized I had, that this could be something that was coming with having drones on our farms. Not necessarily a predator in the machine shed, but something maybe a little smaller. And I started looking around and at what was available, looking at the multi-rotors and the fixed wing devices, realized some of the differences of those, and differences in cost, and the limited budget that I had, which I don't have a big grant budget, but I did have some money left over from a GIS project I'd done with Syngenta on an aerial spraying project that they'd given me some money to help crunch their data for them and geo-reference it. And so with that little bit of extra money, I invested in a Parrot AR 2.0 little, less than $300 drone. And this was my gateway drone. It sucked me in. My fleet is now up to 6. But this got me started because I saw, this ability to get a camera up over the crop and be able to get a perspective that I couldn't get from the ground. And so I invested in this 2 years ago, started playing around with it, found out that it was really easy to fly, operating off of my iPad, a little Wi-Fi link to my iPad or my smartphone, just tilt control. It's landing and takeoff and landing is a touch of a button. It pops up to 3 feet, uses an ultrasonic sensor to sense the ground, and then you take over control and you fly it. It's got 2 cameras, a high definition video camera in the front, another camera mounted in the belly, and I thought, great, I'll get this up out over the crop, take pictures, and it'll work wonderfully. Then I found out that the camera that's in the belly is the lowest resolution camera on a chip I think that's maybe made, and that its reason to be on there isn't to be an imaging device, it's to be a replacement for GPS. Because it doesn't have a GPS, but it uses the image that it sees to stabilize itself over a position. And so it can sense when that image is shifting and adjust its flight to try to stay over that spot. And that's all that that camera is for. In the app on my smartphone, I can switch to the view from that. And when I did that, I was just so disappointed that I couldn't tell anything. It was pretty worthless. But it was a neat device, and I still use it when I'm doing demonstrations inside because I can put the foam cloverleaf on it and fly it around and bump into things without doing any damage. But if you do it in a conference room and there's many papers out on the tables, you can make a little tornado of paperwork here really quick with one of these things. So this was that first summer that I was using the AR drone or experimenting with the AR drone. This was my big image of that summer of a year ago. And this is my nitrogen rate research plot, and got up from the edge of the field up a little bit of altitude looking out over the field, and you could see some of the nitrogen deficient strips showing up from the different rates that I had applied. It may not be real impressive now, or to some other folks, but at this point this was the height of my work with UAVs. And I realized that I really wanted that picture down facing, so I invested in a GoPro, and I strapped a GoPro to the belly of my AR drone and proceeded to almost lose my GoPro after the AR drone started drifting away in a breeze because it didn't hold its position real well, and I crashed it before it got away, and as it hit the ground I saw it bounce and the GoPro come loose and bounce away from it. And I was in knee-high grass, and it spent a couple hours combing through the grass to find my $300 GoPro camera. But when I had first priced the AR drone, it was in my budget. The other option for a multi-rotor, because I decided that was what was going to work best for me with our small research plots and traveling around that I do, I looked at the Phantom 1, and at that point the Phantom 1 was over $800. And that was a little bit outside my budget for something I wasn't sure exactly how I was going to use in my job. So after my failure with the GoPro on the AR drone, I looked back at the market, and the Phantom price had dropped to below $500 with a GoPro mount already on it. So I jumped into the next step of my progression down the line of UAVs. I worked with that and got some good imagery from it that fall, but I really wanted to get into the NDVI or the near infrared. So I looked at what was available off the shelf at a fairly reasonable price, and the best option I could come up with was the Max cameras, the modified lens replacement cameras, and that ended up being probably a $200 camera with a $700 modification in software that came with it, so a $900 investment in a camera. I was going to try to mount that on the Phantom, and I couldn't find a gimbal that would hold it and the Phantom and still fly worth a decent amount. So I decided that winter that I needed to do something else, and I wanted to learn more about it. And so I built a system last winter based on a DJI 550 frame and a gimbal. I talked to a consultant a crop consultant in Canada that had the same camera that I had, and had built a system based on a 550 frame, and he gave me some tips and some ideas of what to use, and so I put my system together and used it all this last summer, flying my NDVI camera or my near infrared camera, and I could actually put the GoPro and the Canon on there at the same time and fly, and covered a lot of acres with that rig this last summer. Close up. I tried to do this without getting a lot of attention, but then in June, the University of Illinois Public Affairs Office had heard that I was doing some stuff with drones, and somebody had a slow day and was looking for a story, and so they called me and said, "We really want to do a story." I said, "I'd rather not. I just want to keep doing this and not get anybody's attention." They were persistent, and I let them come do a story, and then I started getting lots of media calls, and spent a lot of my summer talking to different folks about UAVs. So here's some of the projects and examples of some work and some of the challenges. GoPro cameras, wide angle lens, major amount of fisheye. But with Adobe Lightroom or even the GoPro software that comes free from GoPro, you can just make a couple of clicks and take that out to take the fisheye and correct for those wide-angle views. This is a colleague of mine who puts out a lot of farmer research plots, and he was wanting an image of one of his plots to show to farmers to explain how this experiment was going to be laid out and what a randomized complete block design looks like in the field. And so we went out one day and took a picture of it. And as I've got my, this is with the Phantom, I've got my Phantom up over this, collecting the image, and I look over and there's an Illinois National Guard Black Hawk helicopter coming cross country. And so I'm rapidly pulling down on the stick to get that as low as I can as quickly as possible. I don't think we would have been real close, but I didn't want to be anywhere near him when he came through. Looks like a great day for flying and collecting information about crops, but there's a problem. What's the problem? Shadows, clouds. Get some of these big clouds moving over your imagery and you can definitely mess up, especially if you're trying to take a series of things and we're trying to stitch things together. Really can kind of mess things up. It was still was a pretty day, but you got to watch out for clouds. One of the things that you see right away with these images, even if you're just not doing some of the real high-powered things, but on our research farm, the head agronomist for the farm likes to do the planting. He's actually not very good at it. You can see the skip here and the laps over here. And this is a brand new John Deere planter and tractor with all the bells and whistles and controllers on it. I haven't pointed this out to him though. We took one of our fields at the research farm that was didn't have an experiment on it this year, that was just going to be what we call fill corn, and I told the farm staff just to make mistakes. So they changed the population up several times across the field, turned the nitrogen applicator on and off, and so I collected images over it throughout the summer to see how this would show up in both the near-infrared camera and with the GoPro. We heard mentioned a little at lunch about Palmer amaranth as being a weed that's of real concern. And this is a field just outside Kankakee, Illinois, south of Chicago, that is terribly infested with this Palmer amaranth weed. And so we've got a research plot there on that farm. And you can see some of the areas that haven't had any treatments on them yet. And these are a carpet of Palmer amaranth seedlings in those areas.
What time of year was that? I'm sorry, what time of year was that?
That was early June, last summer. It was the first week of June. This is a cover crop experiment. We've got blocks that were unseeded with cover crop. And we've got areas where we've added nitrogen, and you can see where the cover crop was only doing marginally well in certain areas, but where we had added some additional nitrogen, we got much better growth from our cover crop seedlings. Not normally recommended that you do the oblique view, but when you're just flying around, it's kind of a nice view to look at if you're just doing a kind of a visual survey and not actually trying to collect hard data. But one of the things we saw on this flight, this was any aerial regular aerial applicators in this room right now. You might be familiar with Scott Bredauer from the University of Illinois. He's our guy that coordinates all the aerial applicator calibration. He runs all around the country doing those aerial applicator calibrations. And he and one of his colleagues were putting in a fungicide aerial application study onto this farm. and they were wanted me to come fly over the field to make sure that there weren't any really bad areas for them to put their experiment in. So they want to lay this all out in advance. They give the pilot a map already laid out with the different treatments on it. And so he comes in and flies and pretty much automated puts out what they want. But they'd had problems in the past where they'd laid this out, given the map to the pilot, he'd put it on, and then they'd come in at the end of the season and they'd found out that there were poor crop areas out in their drowned out spots or whatever that messed up their research results. So they wanted me to come in and pre-survey their field and make sure it was a uniform area where they were going to put out their experiments. And so I came in and was flying, this is going to be the center line of their treatment area here that they've cut into the field. But as we were flying this, we realized that even some information the farmer hadn't noticed was that the windstorm the week previously had caused a fair amount of lodged corn out throughout the field. That's kind of the diagonal pattern you're seeing across the rows there, up there, with wind damage that had been causing the corn to go down in patterns out in the field. This is a smaller weed plot. One of our graduate students has got this water hemp. This is chemical or glyphosate resistant water hemp, and these are different treatment blocks that he's got in his experiment that he's doing his PhD on. And so you can see some of the different treatments and the amount of water hemp that's remaining in those blocks. So if there's any companies out there that are wanting to really test some of their sensors, we've got some great experiment fields that might be good for them to fly over. So here's a close-up of from my drone of the corn and the thickness of the weed canopy in there. There was talk about doing populations from imagery and the ability to kind of do an automated population map. Even without that, at this point, you can calculate populations. When I first started thinking about it, I was thinking I was going to have to go out and lay out some kind of a marker, a known distance marker out in the field, so I could calculate some or make some strips out there that I knew the distance of, and I could count the plants in those. But then I realized if I had a good image, I already had a set distance in there that 4 rows, 4 30-inch rows, wrong button, there we go. 4 30-inch rows is 10 feet. And take that same measurement and go down the row and count the number of plants, multiply that number times 1,740, and you'll get the population. So you could do a population count from fairly simple imagery. And there are some of our grad students that really want me to do this, fly their plots so they can stay in the office to do their population counts on. But I've realized I need to be a better pilot to do a steady flight down the field so that we get good uniform imagery over each of their blocks. So I'm going to have to get better at programming the automated control even with just in line of sight. This was my best image of the summer. This was the one that really I've been using a lot this winter with my general farmer meetings about nitrogen rates. This is this year's version of that previous nitrogen plot that I showed with the oblique picture from the AR drone, but this is with the near-infrared camera, straight overhead from mid-July, and you can see the different coloration of the strips correlating to the experimental treatment that's on them, the amount of nitrogen that was applied. We've got a tissue test where we went in and hand sampled leaves from each of those strips and had those analyzed for nitrate content, and we got a great correlation between the nitrate content in the leaf and the coloration we were getting in the strip. We also used a green seeker optical sprayer to do a variable rate nitrogen application in there. And it did a decent job, but it didn't do a very good job.
What spectrum band is this?
This is a Max near infrared, so it's got the notch filter put on it, so it's shoot, I can't. It's yeah, yeah. I think that sounds right. Yeah, they take out the UV filter, they put in their color filter.
Probably between 700 and 1100 meters,
Maybe a little bit, just right on the low side of that, I think.
They've also got a green-red near infrared camera that measures the infrared between 8 and 900.
And they just came out with a version that actually uses, it's a dual mount for 2 cameras, and so they put a visual spectrum camera and made it with one that's got their filter on it, and you can do dual image. Max does, yeah. So kind of the low end of sensors. Which brings me to one of the projects for my next summer is in our ag engineering department, we've got a remote sensing lab, and I was in discussions 2 weeks ago with a professor and his grad student from the remote sensing lab at engineering, and they really want to work on vegetative indexes with visible light. So you could use regular cameras and do digital manipulation of them to do a vegetative index. The professor's theory is that one of the main reasons we're using near infrared is because that's what we're used to, and that's what NASA had to use on satellites to get imagery from space. So there may be some other ways we can do the same thing for low cost, low weight. So we're going to experiment with that this summer, and you do some of the projects over my plots and try both of those approaches and see how we do. So I'm excited about doing that with them. I got drug into some areas I hadn't planned on when I started my project, and one of those was I got a call from the Grain Elevator and Processors Association saying, we see potential for this in our industry of instead of having to dangle a guy on a safety harness over the side of a grain silo to inspect for cracks and look at our equipment. And would you be interested in talking to us at our international meeting in St. Louis? So I did a simulated inspection of a grain facility in Stanford, Illinois, and found out that flying a UAV around a grain facility is a very challenging environment. You have very large concrete and steel structures that create GPS echoes, and so your GPS stabilization is somewhat marginal, and any kind of a breeze gives really wild wind currents around those tall buildings. So that can be somewhat of a challenge. So I think we need some additional sensors, proximity sensors, and stabilization systems, or better GPS that helps compensate for that if we're going to operate very much into that environment. I've had anecdotal discussions with some folks from Growmark, fertilizer company, that some of their field guys are experimenting with them, and some of their facility guys have asked them to come fly their crop UAVs over their fertilizer plants. When they're getting ready to replace the plumbing on some of their tanks that are up in the air, they can run the drone up there, image the plumbing, and they can figure out what fittings they need to buy before they send the crew up there to start replacing things. That's the Stanford grain facility. One of their places where they'd already done a repair that I was inspecting for them, looking at. I also got a call from the Illinois Association of Drainage Districts. They wanted me to talk to their meeting, and so I also went out and did kind of a test flight, or it showed kind of an example of a inspection of a drainage ditch. because they've got lots of miles of drainage ditches to monitor and looking for ways to keep track of what's going on, look for unauthorized tile lines that are going in there, or structures that are failing, or beaver dams, or log jams that are causing problems in their drainage systems. I also discovered during doing this test flight that high voltage power lines are something to be respected. I was down here, it was where I launched from, a quarter mile away over to this side. There was a high voltage power line. I ran away from the power line, down the drainage ditch about a half mile, and turned around and came back. Got back to the launch point, thought I'd just run up to 400 feet, do a panorama to include in my presentation. I got to 400 feet, and at this point, I wasn't going farther away from the power line, but I was getting farther away from my controller and staying the same distance away from the power line. And there was a fairly strong crosswind, and all of a sudden the Phantom started drifting away. And I kicked it into fail-safe mode, and it did not respond and just kept drifting away. It got over a quarter mile away. I'm fiddling with the controller, trying to regain control. I look back in the sky, and I can't find it. And I can hear it, but I can't find it in the sky. I jump in the truck. I drive down the road a quarter mile, jump out. I can hear it. I can't find it. I go a little farther down the road. I can't hear it, can't see it. Drive around the section, see something white out in the field, walk out in there, and it's a grocery bag that's stuck on a corn stalk. This happened to be a chisel plowed field that was quite muddy at the time. I got back, I drove back to the launch point, thinking on the off chance and hoping, keeping my fingers crossed that maybe it flew back. Wasn't there. Spent a day looking, talked to some neighbors. While I was doing my presentation to the drainage district, I got a text message, and I got out of the meeting, I looked at the message, and there's a picture of my drone sitting there in the grass. It was about 40 yards from where I launched, but it was in waist-high prairie grass where I couldn't see it. I got the drone back. It had been sitting out in the snow and drizzle for 3 days. Got my memory card out, looked at it. The time that when I jumped in the truck was when it stopped and started flying back. And there's a great image of my truck driving underneath in the wrong direction. So it hit the half-mile fence that I had set up in the software, stopped, waited, didn't get a response, it flew back. Started to land, was over the original spot, but as it was landing, it got to the second voltage drop and just started landing on its own, and with the breeze, it pushed it off the original location into the higher grass where I couldn't find it. So, got it back. Last one, we've seen kind of some demonstrations of this before, but this is the Pix 4D. They wrote an app for the Phantom that takes control, and you lay a grid over a sample area. With the beta version of the software, the biggest area that it'll do is about 200 meters by 120 meters, but you lay a grid over it. It automatically flies the drone over it, collects images at set points. As soon as it's done, it starts downloading the images. And then you can take those images, put them in the desktop version of the software, and 2 hours later, you have a 3D model of the area that you'd imaged, which is, again, it's like it's CAD, almost CAD level, so you can go in and do measurements, calculate volumes. Just really neat stuff.
What kind of camera system was that used for Pix 4D?
This is the Phantom Vision Plus, Phantom 2 Vision Plus, so it's just the built-in camera that comes on it. The Phantom does not take good enough metadata on the image, so the Pix 4D software has a magic file that it creates that has better GPS coordinates that goes with each image. And so once it's done flying, as long as you have that magic file and all the images, then you can put it together and it will stitch them or put them together and calculate the point cloud and create the 3D surface from it. So this was 140 pictures that it put together to create this 3D model. And this is our National Historic area of our research farm, our round barn complex down at the University Farms in Urbana. So this, and those are our dairy calf hutches there. I'm also kind of helping a vet med project. Some folks there are looking at thermal infrared cameras on drones over feedlots to monitor the health of the cattle, basically take their temperature, see if any pens are starting to have an infection and need to be treated or taken care of. So they're looking at long-term getting drones up over there for hours at a time, or drone, a series of drones to monitor feedlots on a regular basis. So recommendations: try to have some clear objectives. We're heading to figure out where you're going. Find somebody that'll give you some training and support, services. Bottom line comes down to patience, practice, and persistence to get the stuff to work. So, again, thank you for your time. I think we're right on.